So we can see here. Now, follow me. Okay. Before this one, I have an idea. I have a new idea to explain why the force will concentrate in the around the hull. A new idea to explain this one. Do you have any interest to listening? Before that, I explained the yoke. According to the cross section area will be effect when we deal the hill, right? So you can see here like this equation. A zoom element like this element will be effect how the stress will be affect the stress through the x-axis, y-axis, z-axis, right? And the shearing stress around this one, each surface, right? So now you can see, come back to see this. Now we empty. Now we empty part. That means some stress, for example, the sigma y and the shearing y disappear, right? Disappear, and then make the force uneven around here, right? So the energy will be transferred and concentrate one part. It's logic. It's right. And then will be force because all the system force system. We know the balance, right? From the x-axis, y-axis, and z-axis, right? Now the force is unbalanced because we concentrate here. So some part of force will be found a new balance point. For example, it will concentrate around the hill to keep the balance. Okay, right? So there is a lot of how to say it, a lot of pace method to explain one thing. Okay, if you think it is reasonable. Okay. So we come back, we see the see what? See the code, Chinese code. Now we almost started the material part. We now come back to see the code if you can understand the rhythm. For Chinese code, for the material part, it's very easy. We just show some materials. We divided the different level Q235, Q345, Q390, Q420. So you maybe have a question, what's this? Right? Okay, we will discuss later. We leave the question on the blackboard. In what? Okay. And then welding structure, we should control the temperature. Okay, here are tables. the Q235, Q345, Q390, Q420 determine the tension compression bending strength is 215. Shearing stress is 120, 25. So that means a material, this level material made from the factory, if it have this size, it will have this force. This is just the tension compression stress. For example, you can see here Fy. Fy means this one, the material basic behaviors. Okay, understand? Then in the future study, you will study how to calculate this one, right? How to calculate. Right now, in your mind, maybe the sigma only equal to F over the A, right? Right now. But in the future, later, you will be changed. It will be deformed. This basic equation will be changed. But the Fy is constant. Okay. Fy means the basic material behavior. Material behavior you can see here. For different levels of the material, grade of materials, with different size, the force, the bearing force is like here. This is anti-tension force, anti-compression force, anti-bending force is like here. Notice this is not anti-yielding force. Okay, later you will be know that. Welding strength. You can see the design of the welding strength is also have a table, material tables. Okay, let's see the calculation of the flexural member. You can see that normally in Chinese code we give the basic force, basic value, material value of this one, right? Right. Now you can European code. Use European code. Here beginning is the materials. We determine develop different materials, and then show the material behavior in the thread in the different parts. The force constitution in what, in where, in the location, and this is basic of the. You can see here. We normally discuss the material behavior, using the test you can see here. Right now, you will see the thing S2355JR. You can see I leave a word in here, right? This is Chinese code. This is European code. It's the same. Normally it's the same, very close. The S. We determine the S235JR. Okay. If you come back your country, you also can write a code. Every code is copied from the Americans. Okay. Basic value, the first value comes from the USA. Then in China, the condition is different, so we make some change. In European condition different, it will make some change. Okay. So the two S235, you can see the minimal yielding strength. So yielding is which part? This part, right? This part. So where come from? Well, how can we get the 235? Okay, I have a question. If I don't have a question, everyone will not discuss with me. So how can we get this value 235? Remember? For example, we now discuss the material behavior, right? Material behavior. You can see different, even no matter Chinese code or European code, we normally determine the yielding force to mark the material, right? So, how to separate the 235? How to get it? How to get it? Anyone can help? Salom.
So I'm not sure, but maybe we'll be looking at F5 at the difference.
Okay, it's right. It's almost very close. Normally, we discuss the material behavior. Material behavior, we just determine this one, the drudge condition, right? How to get it? Because the material make from the factory, right? The steel, we make it. We choose one steel to have test. Extension this one, right? We get during the extension part, we get this field code, right? We choose a lot of so many codes. We determine this one. The yielding part is which is 235. That means that the steel, the steel we make from this type of steel is 235. Okay, 235. And then we concentration the steel will make we will use the steel to concentration in the site to make a house or factory. The steel will deformations change the shape and the concentration together, and it will be effect that will be applied bearing a force sigma, right? And then we compare. This is the initial force. So during the concentration, we keep to this drudge experiment to make the safety, to make the concentration safety. This is why the first class we almost discuss the material behaviors. This is why. Okay, so no matter European Chinese code, we all discuss one thing to get some basic behavior of the steel or of the steel. Okay, so we come back to the PPT. This is the yielding condition under complex force stress condition. You can see normally the stress, the zoom materials we separate very thin zoom, very small zoom. A zoom will be suffered, will be applied the force around the zoom. This is if they keep the balance, will be following this equation. So according to this this is one arc. This is only the force, only the one axial. We can make it simplified because we suppose that sigma y, sigma z have no force. Surely have no force. We can simplify the equation as 1 plus the mu over the 3 Young's model for the sigma x. This is simplified condition. When the complicated is this equation. Okay. This will you just know that you don't need to understand this one. You can because it's very difficult to explain for you. It is the elastoplasticity mechanisms. Okay, it's different. It's a very high level. If you want to study the master, if you study the master degrees, you will study this one. The yearly information energy of the unit volume can be calculated by this one. Also, we can express by other force conditions. This is yearly equation for describe the force. So now you should know the yearly condition. If the sigma smaller than Fy, the still does not yield. If the sigma bigger than still yield, it will be effect. Now we can see we see the advantages of the steel produced. Normally, how fully define the advantages? How about define the advantages? Why we should study the advantage behaviors of the steel materials? Because the material for using during the survey stage, it will under cyclic loading, right? Cyclic loading applied here. For example, now it is cyclic loading. Years, day by day, year by year, the material will be fatigued. So the definitions is on the continuous repeat loadings when the stress is lowered, the tensional strength or uneven lower than yearly strength, still fatigue periods occurs. And it is belong the brittle periods. The basic knowledge is that for the strategy, it means the force stress around in the cyclic loading around here. In the zoom, for example, this is the element arrangement of the ions, carbon. During cyclic loadings, the arrangement of the small particles will be deformed, rearrangement, right? The structure will be changed. The arrangement will be changed. The position of each ions will change. The position will be changed. Then the behavior of this one will be changed. Normally, this initial samples, the density is very dense. But during the cyclic loadings, it will be loose. That means the strength will be decreased. Will be effect. The strength will be bigger or smaller. Will be effect, and even to make it lose the strength and sudden failures of the component.
You say the stress will reduce or strain?
Strain.
Strain?
I mean strength, not a strain. Strength. stress, strain, strength.
Thank you to understand.
Okay, so the percentage strength determines the. Okay, if I speak Chinese, strength means 强度，强度，强，强。Do you know the 强? What's the mean?
Strength.
强. Whose name is 强? Do you have a friend named 强? This means the strength.
Yeah, strength.
Means the strength. Okay. The body strength depends on the stress concentration and the residual stress and the number of the cyclic stress. So you can see this one is the cyclic loadings of the materials. How to make the particles shaking? It is also you can see that when the force this one is applied force and the burning force of the material. This one is the material basic force, basic stress. Okay, so we want to check this is safety or not safety. We should because now we talk about the delta sigma is affected by the cyclic number of the stress. Cyclic numbers. This n is cyclic numbers, right? N is cyclic number. So when cyclic number increased, that means that the what? The material strength will be decreased, right? So that everyone will be know that, but in this study we make it as an equation, right? This C is a pyramid, beta is a pyramid. Look, you can see it. For different during the when you study this one, when you do this work, 1, 2, 3, 4, 5, 6, 7, 8, the different condition, you can check from the code. If your condition is radial connection or handed connection, well, it belongs to the file. You can see about the C will be this one, the beta will be this one. To calculate the change of the materials and strength. This is also the force burning from by the structures. Okay. Can you understand? So this is fatigue checking. Just know that when doing under the cyclic loadings will be affected by the sigma will be affected by the cyclic numbers. Normally number is very big levels, it will be decreased very gently. Okay. So this is you can check from the later I will find the tables for you, give you. This is no matter Chinese code or European code, you all will be found the same types of the table. Okay? Now is the last part materials. As part of materials, the type of the concentration, the construction steel. We mark it as the steel as Q. In China word, Q. Okay, in European English word, strength. Know that? Q means 强度 ，strength 强度，强度是235兆帕 ，strength is 235. Okay, so the same meaning, but different countries. OK, 235，知道你们 you know the 235 ？OK. So 强度是235 ，strength is 235. OK, strength. This is the name of the steel made from the factory. OK. Then according to the chemical composition and the effect of those things, the quality graduate is divided into A, B, C, D, 4 levels. You can see 2, 3, 5, A level. Is A level. We also can find they also have the Q345, Q390, Q45 are all low orange, high strength construction steel. Low orange, high strength construction steel is generally a sandation steel, so no torsion method is located in this graph. You all know the low area high strength. It's very hard to explain, but I know the Chinese meaning. English meaning I don't know you really understand. This do you don't understand? Really?
Yeah, I know.
Okay, that's enough. How to make the orange?
Yeah.
Compact. Combining difference.
Yeah.
Okay. So so the selection of the steel will be followed four parts. Four parts. The first the selection of the steel it depends on the structure. Depends on the importance of the structure and the component. If some part is very important, like a joint connections, we will use high strength of the steel. If some part will be to allow it a large deformation, we will use some different material. This material will be allowed deformation. Okay, this depends you to design, and also the selection of the steel depends the load properties, like cyclic loading, the static loadings applied on the structures. If the very high level loadings, the force will be different. The force will be different, and the structure will be different. The selection of the steel will be different. And also depends on the connection method. The connection method is like welding. In this class, you will be studying the welding, the bolting. Okay, the welding. Different types of the steel will be have different welding behaviors. Okay, and also the working condition mostly depends on the temperatures, and the cohesion. The most widely used in China, almost 20 years, we normally use the 2Q235A steel because it is suitable for most of the steel structures and also can bearing the cyclic loadings, and also it's very easy for widening structures. The qualities certified should be content of carbon standard 0.2%. Now we talk about the selection of the steel. Now we can see some different types of the steel, different element type of the steel. Plant, hot loaded plant. This is angle steel. Your steel, we marked at angle steel. We marked it as this is L. This is 100.10. That means the two sides is equal. Okay. The two side length is 100. 100 unit is millimeters. Okay. Millimeters. And the 10 is the thickness of the each side. Okay. It's almost finished. And then we also have the unequal leg angle steel. We mark it as 100 point multiply the 80s and the 10s. You can see the long side is 100, short side is 80. The thickness is 10. U steel is we marked as C38. That means the cross section height is the 30 centimeters. And the web thickness is smallest. The double T steel normally we use the I38. That means the cross section is 30. And the H type is like this one. H type we can mark the HW 300.300. That means the height of the H steel is 300 millimeters, and the frame weight also is 300 millimeters. Okay, and the cut teeth shape steel. Normally, the cut the H type, which only shows the top part to make it as a compartment. Some cold formed steel we can divide it as normally are made of 2 to 6 millimeter thick steel sheets, which are formed by cold burning and molding. Profile steel sheet is a thin weld profile which has been used in recent years. The thickness of the profile steel sheets is 0.4 to 2 millimeters. It is used as a light roof complement. for this title, it can be wrote different ages using different formations. Okay, so this class, the material part is finished. According to the you want homework? It's a good question. You want and don't want any response. So you want to have a homework.
Guys, give me a response. Go with.
Wait,
Man,
I don't point. It was on point.
I don't know. I think so. What are 4 different institutions?
So this is still the second way. The second way. So this is not homework. We just discussed about it in the class. Okay. Before this one, before discuss this part, we still have some minutes. You know the different types of the steel, right? And now we can see some different code. We can see the font tables.
Bit a bit.
You can see the okay, anyways, you see my laptop, I will copy this one. You have a rest, almost the body. Everyone have a rest.